Hi, happy Thursday, everyone. Thanks for joining our Lunch and Learn today. Today, we're going to talk about how to shave 50% at least off of cloud costs by using a piece of software that we developed called Memory Machine Cloud. Before I get started, I wanted to introduce the presenters today. My name is Jing She. I lead sales and go-to-market for MemVerge's cloud business. I'll take you guys through a slide overview of the offering. I'll start with the key pain points that we are addressing, most specifically by researchers and principal investigators. And then I have two members of my team on with me today who will each give some detailed demos and walkthroughs of how the product is used. So I also want to introduce Charlie Yu, who's our Director of Field Engineering, and Satish Perry, who's our developer advocate and bioinformatician, joining with me today. And really excited to walk through this session with you. Please feel free at any time to drop questions and comments into the chat. Whoever is not presenting and not speaking will help field the questions, and we can just make this a very interactive session. That generally tends to be the best. So feel free to just raise questions and thoughts that come to mind as we go through the session today. Okay, so with that, I wanted to just start by giving a little bit of background about MemVerge. We are a software company based in San Jose. We were founded in 2017. And one of the earliest things we actually started doing was working with biotech and bioinformatics labs. We were developing memory software that essentially made it easier to checkpoint and snapshot large memory systems. And we were doing things that could help them realize results faster using a variety of different bioinformatics tools on these systems. A few years in, we realized that this ability to checkpoint memory could be really, really useful, and if applied to the cloud, and enable people who need to use the cloud for scientific research to be able to use the cloud in a much more cost-effective way. And I'll go into more details about what that actually means and how that actually works. But just just being in market for about a year and a half now with our cloud product, Memory Machine Cloud, we're being used by a lot of different labs and a lot of different research institutions all around the world. So it's really, really exciting to tell you about the work we've been doing and how our solution is used by researchers. So I want to start by talking about the pain point, the problem that we hear time and time again. This is probably the #1 problem that presents as a barrier to wider cloud adoption in the research community, and that really is cloud cost. Just the sheer expense of using cloud compute compared to perhaps using your local HPC or institutional HPC. I call it being stuck between a rock and a hard place for researchers, because on the one hand, you have a set of different price points in which you can use the cloud. These are basically the same machines, but they're marketed and sold to you in different ways, in different price levels. So many of you are probably aware of this most common option called on-demand compute, which is no contract commitment, but it's also the most expensive type of compute. There's other ways to save money or get a discount on your cloud compute if you're willing to commit into a long-term agreement, sometimes at least a year, and many times beyond, one year into the 2 to 3 year time frames, just to get, a 20, 30, 40, or 50% discount in the cloud. But for research teams, this isn't always a possibility, because you may not know how much compute you actually need at the start of your project. So how can you commit so much of your research budget towards things like reserved instances and cloud savings plans? So then you have another option, which is called spot instances. These are the exact same machines. You get the same number of cores, the same amount of memory in each of the cloud platforms. But spot instances are and can be, in some cases, 70, 80% less than the on-demand price. And what you see on the right here is just a representative sample of different instance types, different numbers of cores, different numbers of memory, and different generations of CPU families that are available on AWS. And you can see that the savings over on demand of these spot instances are quite attractive. So in general, you can expect at least 50 to 60% less cost by simply being able to use spot instances. But there is a catch. And the catch is for spot instances, you're not guaranteed to keep your instance. And what that means is the cloud provider can reclaim or interrupt your use of that spot instance with just a very short warning. So on AWS, you get 2 minutes. On Google Cloud and Azure, you only get 30 seconds. So if you're in the middle of running a very computational analysis that may take hours and sometimes may even take days, it can be very, very tricky and difficult to complete an analysis running on spot instances without the help of our software. And the other pain point that we're addressing is this cloud skills gap. And many researchers are coming from like a university HPC lab context. And so even simple things like, okay, if I have a cloud account now, how do I actually run a job on AWS or GCP? How do I know that I'm using the right compute for the analysis that I need to perform? And how can I optimize these jobs over time so that I'm not wasting money running on machines that are too large for the actual workload that I need, or with the wrong mix of CPU and memory resources? And also, if I have a team and I'm using the cloud, how do I monitor all of the activity that's going on? How do I track it? And how do I keep track of the different users who may also be using the cloud for the research project that we're all working on? And there's many ways to address these questions, but a lot of those ways today are manual. And so is there a way to utilize software that can help do a number of these different tasks and basically bridge that skills gap or that learning curve to be able to productively use the cloud? So I'll go into a little bit more about what it is that our software is actually doing. And there's a number of different ways that the Memory Machine Cloud software is helping you to address the number one issue being it's too expensive to run on the cloud. Let me go through these different points with you. And then what I'll do in the next few slides is actually show you real examples, real customer workloads where these different capabilities that we've developed in our software product are being used to reduce your cloud cost and many times also optimize the performance of running in the cloud. So starting with the first one, what we call WaveRider, it's the ability to move a workload from a machine that might be either too small or too large in the right direction so that your application is running on the right size of machine. When we do this, the application that's running does not have to be terminated and it does not have to restart from the beginning. We're able to actually move workloads that might need more memory or CPU to larger machines so that they don't crash. And alternatively, we're able to move workloads that might have started on a machine that was far too large and you're just overspending by paying for cores and memory that you don't need to a much smaller machine where the application is right-sized so that you're only spending on the compute and memory resources that you actually need to run that job. The second area that our software focuses on is this concept of EC2 automation or compute automation. If you're using Google Cloud, it's Google Cloud VM automation, and also instance selection. What this means is we are going and interfacing with the cloud infrastructure provider for you, our software is, And we're locating and we're identifying the best compute based on a few simple inputs that you're giving us. And instance selection is simply the ability to tell us from the hundreds of SKUs that each of the cloud providers provide for you. It's a way for you to limit and make sure that we're running on the best families of compute for the workloads that you have as you get comfortable with the research that you're doing on the cloud. The third, which is actually a file system point. This is an area where you may think that compute spend is an independent variable relative to your storage or your file system environment. But what we've seen is by implementing the right file system for certain workloads, you actually can reduce the wall time or reduce the total CPU time required to run through an analysis or a pipeline. And so I'll go into some more details about how that works as well. And the ability to easily suspend, resume VMs that are running different applications. For example, you might be using a Jupyter Notebook or RStudio environment in the cloud. The ability to simply suspend and resume these instances, let's say overnight or over the weekend, whenever you're not using it, it's simply another way to optimize the compute spend that you would otherwise have by leaving these types of applications and machines on 24/7. And then lastly, the biggest ticket line item in terms of savings is this ability to run on spot instances. And we have a very unique way of doing it. We call it spot surfing or SpotSurfer, the feature. And we address the main challenge for most users to adopt spot instances. And the challenge is that if my workload's not done and the cloud provider takes that spot instance away, do I really have to restart this workload from the beginning? Do I really lose all my work? And the Memory Machine cloud software is built with an automatic checkpoint and restore feature set. And the way it works in the event that the cloud provider is taking the spot instance away is that it's able to automatically checkpoint and take that memory snapshot that I talked about earlier in the presentation. We're able to take that memory snapshot and then resume this running state of a job or application onto a new EC2 instance or a new Google Cloud VM that we are provisioning back up for you. And so in this way, you're not losing the progress of the workloads that you're running, even though you're running it on spot instances. So it's as if you're running a workload continuously from the beginning to the end. It might take multiple spot instances to get to the finish line, but you're not having to restart from the beginning. So you're not losing, you're not being penalized on the wall time, and you're also able to take advantage of these extreme cost savings that spot instances offer you. If there's any questions so far, please just drop them into the chat. We're happy to address them as we go here. But hopefully, conceptually, this makes sense. There's a number of different areas that it's possible to now apply different software techniques and software automations in the cloud, which can help lower the cloud cost for scientific research. So I wanted to show you this first exhibit. This is a customer workload focused on fine detailed mapping analysis. There's a few things that I want to point out in terms of how the Memory Machine cloud software is saving this customer cloud costs. The first is you'll see what's circled in the orange circle on the graph. This is this visual here comes from our product. It's called WaveWatcher. You get a nice machine resource utilization profile of each and every job that you run. And this particular area that I circled is an area where the job was about to run out of memory. So for the majority of this 9-hour analysis, the smaller machine was sufficient, but just towards the end, there must have been some functions in the tool or in the job script which required it to perform a set of actions that needed more memory. And normally this would have simply crashed due to hitting an out of memory error. But the Memory Machine cloud software, which is running this analysis or this job for the end user, it was able to detect that the out of memory condition was about to be hit. And it was able to automatically look for a larger machine, at the same time taking that memory snapshot or that checkpoint of the workload, and we moved it to a larger machine so that it was able to continue running for that last 1 or 2 hours and complete instead of failing. The second thing that this workload was able to take advantage of is our what's called spot first selection logic. So when you're running a job using our software, you can think about it as like an HPC head node with a built-in job scheduler and a resource manager. You're able to tell us to run in a default mode, which always prefers spot instances. So by doing this, you don't have to worry about which instance do I need to use or spin up to run this particular job. Our software is doing that for you, and it's saving you the time and energy from having to go and decide which instances that you need to run. And also, this particular workload worked better with a high memory, less CPU ratio machine type family. And so the instance selection logic was restricted to the R5, R6, and R7 families in AWS, which if you're familiar with AWS, those are the memory optimized instance families. And then lastly, this entire 9+ hour analysis, it only cost less than $1 and was able to run on spot instances for almost the entire 9 to 10 hours of runtime. And so in this particular case, if this person had run on a larger instance and not on spot, they would have spent more than double what the cost of this particular job cost in reality. Okay, I wanted to, in the next exhibit, this is an alignment step or an alignment process that one of our customers ran. This is an axolotl data sample, which is from a genomics standpoint, it's like 10 times more complex in terms of the number of base pairs than even the human genome. This particular BWA MEM step took 38 hours to run, and we were able to run it on spot instances the entire time, but it took saving this job 36 times. So there's 36 spot interruptions to get from the beginning to the very end of this job. And normally this would have been a very difficult type of analysis to run on spot instances, just due to how long it runs for, and also just the frequency of interruptions that we saw. But just like in the prior, by using the SpotSurfer feature set, our software was able to continuously save the progress of this job and continue running it on new instances that we were able to provision up each time there was a spot reclaim. And you can see that this was another example of how, by being able to run on spot and survive spot instance interruptions, the user was able to save a significant portion of their compute costs. I also wanted to highlight some benchmarks because one of the other areas that the MemVerge software is used for is not just to run like individual research jobs, but it can also be used to run entire pipelines. In this case, we did a benchmark on the RNA-seq NF core pipeline. And you can see that the Cloud way of running compared to using the cloud native batch scheduler called AWS Batch, it was able to run it both with less CPU hours and at dramatically lower costs across the board, regardless of if you're running using spot instances or on-demand instances. And part of that, part of this example highlights the value of some of our file system optimizations and automations, and also the fact that our instance selection logic is really nice and optimized when you're running these pipelines. We generally are running with only the right sized VM that you need for each and every job. and we're not over provisioning the size of the VM for the jobs that we're running. And so these are some of the factors that also contributed to this dramatic benefit in terms of the cost versus the cost and the runtime. Okay, and I also wanted to share another exhibit, which is some additional benchmarks that we did with more of the Nextflow pipelines that are commonly used by the NF Core community. You can see here that the lower bars are better, the higher bars are either are more cost. So the two blue bars in the chart, those are when Cloud was used for both on-demand instances and to run the same pipelines on Spot instances. And you can see that the savings that you're getting by running with Cloud are anywhere from 69 to 78% less than if you were to run it without our software. And one of the really interesting points in this particular benchmark is if you look at the Sarek results, the Spot AWS batch run actually ended up costing more than the AWS batch on-demand run. Why is that? Well, part of the risk that you would be taking by using Spot instances is that you can lose the instance and have to retry from the beginning again. And in the benchmark that we did with AWS batch on Spot, we did see that there were numerous reclaims that drove the total cost of running the Sarek pipeline to be actually even higher than the cost of running it on demand just one time through. And so what the Memory Machine Cloud software is doing in this case is it's providing a consistent, predictable runtime and also per cost per run, even though you're using Spot instances, because we're not forcing you to have to lose your work and rerun it from the beginning again. Okay, and this is a so pivoting from the pipeline use case, I wanted to also show the Jupyter Notebook or interactive computing use case, which is another area that we that you're able to use our software to reduce the cost of running these types of environments in the cloud. This particular screenshot is of a Jupyter Notebook that has been running for 72 days. During those 72 days, there were 8 different times in which the cloud provider, in this case AWS, reclaimed the Spot instance. And normally, if you were working out of a Jupyter Notebook environment, in this case, you would have lost the environment. You would have had to restart from the beginning on basically a clean Jupyter Notebook restart. Instead, the way that our software behaved in these interruption instances were that we were able to find another VM and reprovision back the Jupyter Notebook environment as if you had left it uninterrupted. And by doing this, the cost of just standing up different interactive computing environments for a team of users in a lab, it can be quite affordable. So in this case, 72 days of runtime, less than $33. Basically, that's less than your morning coffee to keep a computing instance up and running for a user in the cloud. And normally this would have cost more than double that to do. Okay, I'm almost towards the end of showing the different exhibits, and we'll start going into the demos soon. I did want to show 1 or 2 additional examples of also different ways that an interactive computing environment is enhanced by our software in the cloud. This is an example of being able to wave ride a Jupyter Notebook. So the thinking here is that you don't always need a big machine for the work that you're trying to do. If you're just coding, you shouldn't need it, or if you're just exploring, if you're just coding, you don't need a big machine. In this example, you see that the instance originally was provisioned on just a 2-core, 4-gigabyte machine. But then what if I need to start working with some data? I might need to keep more data in a data frame using various packages and tools in my interactive computing environment. I can then move myself up to a larger machine where I'll have more resources to work with larger data sets. And then after a couple of hours I might be done and I might be back to working on some code, I can then move myself down to a smaller machine. And this is yet another way where you can optimize the cost of running these types of environments. Basically, you don't have to have a large machine up and running at all times just to handle a few peak periods where you might be working with more data and you need the larger machine. This is a really nice way to manage the cloud costs by only bursting up to the large machines when you need those peaks. Okay, and this is just a view of what it looks like to start using our software. This is the cost summary, which is the first thing you see once you log in. One of our customers is a lab at Columbia University. The really nice thing about their experience using our product was they were coming from a context of not having any AWS experience. And in just a matter of months, they were able to dramatically increase the amount of compute that they were able to access to accelerate the research that they were doing. They were sharing about 100 computing nodes across 9 different labs in the department locally. And by having this memory machine cloud environment, they're now able to burst, in some cases, 700, 800, 900 computing nodes at a single given point in time, all running on Spot instances so that you're saving a lot of money. And the research was dramatically accelerated by doing this. Okay, and yeah, just wanted to quickly highlight the customer testimonials and what people ultimately are getting from using the software. It really comes down to dollars and cents. The cloud doesn't have to be expensive, especially if you have software that automates how the cloud resources are provisioned and deprovisioned, and especially if you have software capabilities that allow you to consistently and reliably run on Spot instances. So hopefully that hits home all the different points that I covered over the last few minutes here. And that's really it in terms of slides. I wanted to leave plenty of time for you guys to actually see how the product is used. And I'll hand it over to Charlie for the next step. And I'll stop sharing my screen here.
All right, thank you, Jim. Let me share my screen. Are you guys able to see my screen?
Yep, we can see it.
Okay, great. Yeah, so let's kind of piggyback to what Jim was saying about the PI at Columbia University. So he's been running the product for quite some time now. And this is sort of the latest update from him. You can see here the cloud cost and the savings has continued to climb. And in typical fashion, he can see greater than 50% savings from leveraging our product. So let's go into the actual demo and then see what would like to be running a job, running an independent application, genomic application to realize all this benefit. So let's walk through some example here. So let me submit a job. So let's assume I have a very basic batch script that we have developed, and I just want to run this job in the cloud, and then to see how exactly that works. So let me first find my script. So I probably just go to my my tool here and then just copy and paste this bash script, and then I can come over here and specify what application I want to run. So let's say this is the cell ranger I want to run, and I'll give a name called the demo cell ranger (1). And in the job script, I can simply and then paste this script in here, this bash script here. And the next section is where I can specify the CPU and the memory I want to use for running this job. So I'll put down, let's say, 2 CPU and then 4 gig of memory. And then over here, there's a section called VM policy. Typically, I leave that as a default. It's a spot first. Essentially, I will always look for a spot instance at the very beginning. And if it cannot find any spot instances, it will retry a few times and then will fall over to on demand just to make sure that the job continues running. And while it's on demand, it will continue to look for a spot in the background. And then if there is a spot available, it will fall over to running on the spot instances. So we'll leave as spot. And then the last piece is the storage volume. So when I run this job, typically we need some kind of a scratch space for stage the data onto this VM. So we'll just specify 10 GB of storage, and then we'll mount it on the /data mount point. So with this information, that's all I need to get a very basic job running. So I'll simply click on submit, and that job goes into the job section, and you can see here this job is being initialized. So before this webinar, I ran some of the jobs, the cell ranger already. So let me show you what they look like. So if I click on one of those jobs, you can see here this job finishes in about 6 minutes. And under Wave Watcher, we can see the progression of the job over time. We can look at the memory, CPU, network bandwidth, storage, throughput, usage, IOPS, and all that. So all that information gets plotted in real time as the job is running. So that would be an example of a basic job. So once I have this job, right, one of the things we can do to make really, really easy to repeat this job, so anyone can go in there and then rerun this job very easily, is by leverage a feature in the product we call the job templates. So if you look at some of these jobs that we have finished, right, the exact cell ranger job, I can actually click on more actions and then save as template. And this will create a template that I can run this job over and over again without ever have to go in there and then copy and paste my bash script. So I did just that before the meeting. And under private templates, you can see here, cell rangers here. And if I want to repeat the whole process again, I can simply click here, and you can see the job content, the whole script is right here. And I don't need to worry about any of this. I can just click on submit the job. And then I can hit submit to submit this job again, right? If I want to change the CPU, a memory size, I can do that. But if I choose to just leave everything the exact same way as the previous one, which is 2 CPU 4 GB memory, I can just leave as is, and I don't have to change anything. Submit, and we'll kick off another job. So that's how you can leverage this template to make things a lot easier. There are other things we mentioned earlier in the webinar around the selection process. It turns out that if you look at all the instances AWS provide or any cloud provider provide, it has a range of different kind of VMs, right? From general purpose to compute optimized, memory optimized, storage optimized, and so forth. And some of the CPU, some of the VMs using a really, really old technology, like for example, this T2 right here uses Intel Haswell CPU and Broadwell CPU. And these are the CPU families going back more than 10 years ago. So the choice is, do we want to use that kind of a CPU for our genomics memory and CPU intensive workload? Probably not, right? So how do we eliminate some of these lower end CPU and then really take advantage of some of the latest, for example, isolate in CPU or some of the latest generation AMD CPUs? So that's where when you submit a job, you can actually leverage a feature called allow list and a deny list. So over here, I can simply type in if I want to use M families, M star, M5 star, or C5 star. I can specify these families, and that will allow me to concentrate using some of the more advanced CPU technology, a newer CPU available for my job. And then the other thing we also mentioned earlier is WaveRider, right? It's the ability to, number one is to avoid out of memory situation for these jobs, right? So we don't have to worry about application crash, things like that, and also be able to scale to vertical scale to more CPU cores or more memory when the application requires, and then scale down to less CPU and then less memory at the stage of the computation when there's less is desirable, right? To save money on the cloud cost. So I can turn these on as well. So with these features all available to us now, I can submit the job again, and then you will see the next job is running with these new settings. So that's a quick overview on how to deploy a independent application jobs. To find more of these applications that you can launch, simply go into App Library, and these are some of the built-in apps available on the platform. And you can certainly add your own by clicking on the private and add image, and by basically specify the image location, whether it's on Docker Hub, on the cloud platform, such as the AWS ECR, and or even on your local laptop, you can specify the image location, you can add it, and that becomes available for you to deploy it on the Cloud platform. So it's very easy to do that. Okay. So the other thing we showed earlier is launching these kind of interactive applications, such as Jupyter, such as RStudio. Because after you're running these long pipelines, this long running analysis, the ability to looking at all these results graphically will be very, very helpful. So we also support these type of interactive applications. The way we do that is very similar to what you've seen before. If you want to deploy a Jupyter workload, simply submit a job by specifying some of the parameters, such as, well, for this application in particular, you want to specify the security group. By doing that, you can submit a new Jupyter workload. And it works the same way as the cell ranger you saw earlier. So I kicked off a few of them earlier today, and you can see here, we can launch them. And let's see, let's pick this one. And this the Jupyter session is running, and then you can interact with these sessions. If it's a Spot instance, it will be protected against data loss. It'll be reclaimed, but it will be moved on to a new instance. If you're running on-demand instance, you have the ability to, suspend this instance when you're not using it, and then resume the instance when you're ready to use them again. So it works something like this. On your browser, you will see a widget, and this widget allows you to suspend and then resume from here, right? So if you happen to using the instance during the day, you can keep them running, and at night you can automate the process to suspend these instances, right? And that will save you additional cost on these interactive workload. And then in many cases, you may also have some of the workload that you run on premise. You may have HPC cluster in your own environment. So how do you sort of take advantage of this cloud platform so that, once you run out the resource on your local HPC cluster, so these jobs can be pushed sort of a spill over to the cloud? Or in some case, you can just specify the cloud as your queue to push those jobs from HPC. So to do that, actually, it's very simple as well. We have something called HPC Bridge. You can think about that as an extension of Cloud, or you can think about that as add a wrapper for your Slurm, for example. Over here, I basically running this s batch command, and then this is the job file, and this -p specify the queue in Slurm I want to push the job to. So over here, I simply specify the cloud queue, and then by doing that, this will allow me to push these jobs into the AWS account, and as you can see, this job is now running on the MM Cloud. And once they kick off, they will show up on the AWS side. Okay. So that's all I have for you on the overall management, the usage of the MM Cloud from our GUI. And I'll hand over to my colleague Satish, and he will dive into some other use cases, including running Nextflow pipelines. So I will stop sharing.
Yeah, thanks, Charlie. Okay, I'm gonna share my screen here. I first want to point out our website is at mmcloud.io. Jing, if you can put the link for it in the chat for easy access as well. Here you'll find under resources on quick guides, you'll find all the documentation that we have. So you can look at this at your own pace. But essentially, we have been talking about Cloud platform. Let me talk about like the deployment of our platform as well. So currently we support both AWS and Google Clouds. For both of these, we are integrated through their marketplaces. So if you want to deploy an AWS, you go to AWS Marketplace, subscribe to our software, sign up for an Cloud account, and then your license is activated. As Jing put out in the chat, initially everyone gets 30-day free trial of this usage. So through AWS Marketplace or through Google Marketplace. So the idea is that we deploy our software on a single VM instance. So this will be the head node that Jing was talking to about. So this head node is what we call as the operation center, and the interface looks something like this, what Charlie was showing to you earlier. So this is the operation center, that is like the job scheduler, the manager, and also your window into viewing your job status via the GUI. But I also do want to mention that our software, the job scheduler that's working behind the scenes, we also have a command line interface for it. So once you have the op center deployed on an instance, you can install our executable, our float executable on any local machine, and just having the IP address of your of the instance that is running your op center, you can connect from any local machine to this operation center, and then submit jobs, view the status of your jobs. So I just want to stress that there is there's an equally, we have a GUI component, but we also have an equally CLI command line component that users who are comfortable with either of them can use for interacting with our platform. Okay, so just a quick tour of the op center as well. This is a cost summary dashboard. You get a nice dashboard on how many instances have been used, how many spot instances, how many on-demand instances, and the cost and the breakdown per job as well. Then you have the jobs dashboard. This is particularly for seeing all the individual jobs that are running. And additionally, for the support that we have for Nextflow, which is a very popular workflow manager, we do provide workflow level views as well, such that when someone launches an Nextflow workflow, they're able to get an aggregated view of the workflow stats, including all the jobs that are associated with that workflow. the wall time for running the entire workflow, the CPU time, and most importantly, the cost associated for this workflow. So this gives you a very nice view of getting a per sample cost analysis with this workflow view. And you can also see how many instances it was run on Spot, how many on demand, and in case if there were any Spot interruptions, how many migrations did we have to do in order to successfully save that job. So you get all this nice in a workflow level aggregated view. So in the docs, if you see, we have initially introduction to Amazon Cloud, or if you're on GCP, we have instructions to deploying the our operations center or ops center. And the solution particularly we have for Nextflow is what we call as Juice Flow. This is particularly interesting for Nextflow users because this introduces a highly performant file system called JuiceFS, which is open source. So we have kind of integrated it into our platform such that all Nextflow jobs automatically use this highly performant JuiceFS file system that basically mounts buckets in either S3 or GCP as the backend. So just to show what we have, actually Nextflow is one of our most hardened product, one of the product lines. Basically, how we interact with Nextflow is we have created a plugin. Let me actually just expand to show you some of the script that we have. So we have basically created a plugin to interact with Nextflow so that the plugin will now make use of changing the executor in Nextflow to what we call as float, which is our job management service. So we use this plugin to basically reroute any jobs from Nextflow onto our platform. And because of this, because of our integration into Nextflow at this plugin level, you are able to actually customize your Nextflow pipeline a lot more, such that you, by default, you can see, actually, let me show it in my VS Code so it's much more clear. Just diving a little more into the technicalities here. So when you're using Nextflow, using our plugin, in the process executor, you change the executor to float. And in the extra section, you can see you can specify VM policies, either by default to apply to all Nextflow processes or using the with name selectors in Nextflow, such that if you have a BWMM job and you want to make sure that this particular job goes to an on-demand instance, for instance, or if you wanted to set a particular type of instance type to run for this particular job, you can now customize on a per process level within Nextflow using using our plugin. So this gives you this huge advantage of being able to customize your pipeline such that it uses the right kind of instances and the right type of resources. But yeah, other than that, so the JuiceFlow solution, as I said, it uses JuiceFS, and that actually speaks to some of the additional savings that we are able to offer our customers by not only using Spot instances, but also using this highly performant file system, such that your Nextflow tasks and processes finish much faster. And you're able to make use of the cheap S3 storage that's available on AWS or GCS. So this is the instructions for running. So this is a quick start guide that's available on our website. And users can also, so that's for the command, that's for people who are comfortable with the command line. But as Charlie pointed out, we do also offer private templates where users can store or create templates for different pipelines that a lab might be using. So anyone who is not comfortable with the CLI is actually able to make use of the GUI to submit jobs as well. So users have that flexibility. And coming to users and group management, I mean, you can have one operation center cater to multiple users. So you can create users within the user groups, and they'll log in. They'll have their own account, and you can also assign them different kinds of permissions and roles, such that either they can use the Op Center just for viewing the results, or also being able to submit jobs using the Op Center. And another useful feature that we have to avoid any unexpected cloud spend is what we call as the serve zone. So this is basically quota management system where you can assign a certain amount of quota or dollar spend for each user, such that when that quota is met for that particular user, either the jobs are canceled or checkpointed and stored, such that again, when the quota is refreshed, jobs can continue back again. So this is one feature where you can use to avoid any unnecessary, unexpected cloud burst spends on the cloud as well. And there are a lot more other features for the entire operations center settings. So what you're seeing here is an admin level view, but you can, as I said, you can create different users. So recently we conducted multiple workshops. We see this as a good training platform as well. So we conducted multiple workshops at Rockefeller University and also at MDI Bio Lab, where we were teaching how to run large bioinformatic workloads on the cloud using Spot instances. So we spin up an operation center, we create multiple user accounts for all the trainees that will be attending, and they all get to log in and submit jobs onto the cloud, either using the private templates that we have created for them, or if they're comfortable with command line, our quick start guide on using JuiceFlow for Nextflow pipelines especially walks them through all the steps involved for submitting via the command line. So this, yeah, that's what I wanted to quickly give a tour about. And I think that's what we had planned for you all today. So I think I'll give it back to Jing now.
Great, thanks, Satish.
Yeah.
I know we just have 2 to 3 minutes left in the hour that we scheduled for this. Hopefully it was helpful to all of you who attended. If you have any other questions, we still have a few minutes to take any additional ones, and we can just answer them live.
Yeah, addressing the privacy concerns. So just so as Jing pointed out, we deploy the software deploys within your VPC. So the data is basically within your network. So as long as your VPC is built out for HIPAA compliance, our software should be too. So we basically call this as HIPAA eligible. So it's totally dependent on how your setup is in the cloud.
Great, thanks, Satish.
There's one. I noticed AWS has own EC2 Spot, so why select Cloud? Yeah, so yeah, right. AWS and GCP both have their own Spot, but they don't come with this checkpoint and restore feature. So you will essentially be rerunning the entire job again when a Spot reclaim happens when you're using native AWS EC2 Spot. But using Cloud, I mean, we are using the same EC2 Spot instances as well on AWS and EC2 on GCP. It's just that for those Spot instances, if at all there's a reclamation, we can checkpoint, take a snapshot of the running job, including everything that is in memory, find another Spot instance and restore it on there, so that you basically are not rerunning the entire job again, not starting from scratch, but also getting an automated way to find another Spot instance and get the job continuing there. So that's the basic difference between using AWS EC2 Spot natively versus using MM Cloud.
Yeah, and
just to-
don't let the name MM Cloud lead you to think that we have our own cloud service. It's software that is helping you manage your EC2 instances in the example of being on AWS. And we have this really unique way, as Satish described, of being able to run Spot instances in a better way.